In this video, I am going to give you some techniques that you can use when you have multiple samples and you want to map each of these samples to a reference sequence. Now, let's take a look at this situation here. I have some Pascal files here. Let me do an ls into that directory. And so I have these files. I have 3 samples here. So this is sample 1, that's further sample 2, and also have sample 3. Sometimes you may have more than 3 samples. You may have tens of samples, hundreds of samples, or whatever. So if you have lots of samples and you want to perform genome mapping, then you need to develop a strategy that you can use. And sometimes can be challenging, especially for beginners and for those who are less experienced when it comes to programming and writing pipelines. So for this tutorial, we are going to go step by step. I'll give you the step-by-step procedure that you can use to build a pipeline, and that can be used to map your FASTQ files to a reference sequence. So by the end of this tutorial, you will write a script, and in that script, you can use that to iterate over the samples that you have and then perform your mapping. The script that we are going to develop, you can use it on your own data sets. I will show you how to tweak these scripts and then make it more generic as we go along. So let's start. So for this tutorial, we are going to use these files. And these files, the links can be found on this page. I'll show you the page. Let's go there. The files can be found on this page. So I am using data sets that was used to make this tutorial. This is a Galaxy tutorial. I'm using the files that were used in that tutorial. So these are the files. We have 3 samples here. We are dealing with paired and read. So in total, we have 6 files. So a pair of files belong to a sample. So we are going to download these files, and we're also going to use the reference sequence, which is here. It should be somewhere here. Yeah, this is what we are going to use. Now, for this tutorial, if you want to follow it, you need to make sure you have these tools installed. You need to have BWA installed, and you also need to have some tools installed. These tools can be executed on Unix-like operating systems, i.e. macOS and Linux. So you need to make sure you are running either macOS or Linux, and then you can install these tools. I have tutorials that show how to install BWA and then some tools. So if you are new into this field, then you can watch those tutorials to set up your PC. The links to those videos are in the description box. So check the description box and then use the videos to set up your PC. So now let's proceed. So let's get back to the Galaxy page again, and then first download the file. So I am here. First of all, I'm going to get the links to these files. Okay, we have 6 of them. That's for the FASTQ files, and we also have the one for the reference sequence. So we have a total of 7 files. So here again, I'm going to do some automation here, which I'll show you. It's basically the same principle that we use for the mapping activity itself. So I'll first get the links, and then I'll show you what to do next. So let's go back to the terminal. And now we can start the exercise. So first of all, let's create a directory. So I'll say make the mapping, and then I'll seed into it. So this directory becomes my working directory. So I am now in. So as I'm here, I'll first create a script that I'll use for downloading the files. I'll also create a text file which has all the links that I'm going to use to download the files. And so first of all, let me create a text file which has the links, or which we will place in the links. So I'll say nano links.txt. I'm using the nano text editor, but you can use VI or any text editor for that matter. It's fine. So just make sure you have this file opened. So I have opened this text file. So I'm going to copy and paste the links here. So let's get all these links. I'll copy them. and then I'm going to paste them here. I have the files here. I'm also going to get the reference sequence. So I'll scroll down to this side here and I'll get the link. So this is the reference sequence. I'll copy that. And then I'm going to paste it here. Okay, so I have all these files there. So now I'm going to close this. Perfect, that has been done. So let's do this. Now we are going to automate this process. So we can decide to create a script to do that, or we can decide to do everything on a timeline. It's up to you. It's basically the same thing. Okay, so let's do this. I'm going to download the files and I'm going to use wget. You can also use curl or any downloader, but I prefer to use wget because I'm using a Linux system. So I would like to use that one. So this is how we are going to do it. I am going to create a bash script and then I'll use that to download the file. So I'll say nano download.sh, then I'll put my shebang line. And then when I come here, the next line, that's what I'm going to do. I'm first going to get the content of the text file. So I'll say links equals, and I'll bring this here, and I'll say dollar. I'll explain everything. So let me first do a cat links.txt. So this is it. So here the cat is used to display content in the text file. Okay. So what I'm doing here is that the contents, everything here. Okay. The dollar here tells bash that everything, the outputs, okay, of this command here should be placed here in an array. We call this an array. So we have another parenthesis here, this and then this. So this means that the output should be placed in a bash array. So arrays, they act as, let me put it this way, they act as containers that can be used to store data. I'm using the word container here. It's not really scientific, but I'm just using it so that beginners can have an idea of what's there. So arrays are data types. It's a kind of data type that is used to store data basically, but it's more like a container if you put it in the layman's term. So basically it's used for storing data. That's it. So that's what this one and then this one are going to do for us. And then this one here, this dollar, and then this parenthesis, the second one, the inner one here, telling bash that the contents, the result, the outputs, everything we want it, and we should put it in a bash array. That's what we've done here. Okay, so now we have done it. So now that we have the links, what we need to do is to iterate. So we are going to use a for loop here. Okay, so for loop is used to iterate over some data types. Okay, so it's just like, let's say you have, let's say, some numbers, let's say 1 to 10, and you want to get all these numbers, or you want to see these numbers, or you want to process these numbers. So you have to take them one by one and then process them. So this time we are using a for loop. So I will say for link in. Now bring this links. So this here, what we are doing is that we want to get everything here, everything in this links array. That's what we get here. So this is what this command is. So this tells us that we want everything to be returned to us. All the links that are in this array. That is what this here that's for. So everything, and then we iterate. So that's where this one comes. So this link here is a placeholder, so that we can pick each of these elements, each of these links here, and then process them. That's basically what we are doing. So we use the for loop, and in the next line we say do, because this is the rule in bash. And then we come here and then we give the command. So this time I'll say wget, and then I'll say $link. That means that we are issuing wgets here, then we supply it with a link. Okay, this is the link, but then we use dollar here so that it tells us that we want the actual value that has been assigned to the link variable. Okay, so that's what we have here. So the values are going to change because we are going to pick each of the links here and then process. That's what we are doing now. And I will say done. This is a simple script. So that's what we have. So we can close it and then we type Y and then we save the changes. So now we can execute the command. So if you want to execute, there are two ways. You can use bash for the script here, or you can also say // and then give the name. But if you use / here, you may get an error message unless you add execution rights. So let's add execution right. We can say chmod +x and then we specify the file name here. That's it. But you can do an ls first just before you issue this command to see that you have the file there. But I have done it a couple of times, so I know the file is already there, the script is there. Okay, so now I'm going to execute this script to download all the files. So I'll say // and then I'll specify the script. So let's execute the script. Perfect. So now we can see that the files are being downloaded. We are starting with father R1 and then you move to R2 and then we go to mother and we go to program. So we are going to have all the files downloaded for us. Now we have automated the process. So this now it's very convenient because we don't have to specify wget and give the links for each of the files individually. Okay, we've just had the script that will do everything for us. So if you have hundreds or thousands of download links, then you can use this approach to get all the files for your analysis. So let's wait for the files to be downloaded. Okay, the files have been downloaded, so let's check them out. Let's do an ls and we will find the files here. What we are going to do next is to unzip the reference sequence. Currently, it's zipped, so we need to extract the FASTA file. So this is how we will do it. We will say unzip, and then we will specify the file name. So let's unzip it. Okay, the file has been unzipped. So let's do an ls, and we are going to find it here. So this is it. Notice previously it was this one plus the .gz, but now we have up to .fa. So that means that we have unzipped it. So now we have the FASTA file. So that's what we need. Now we are going to move all the FASTA files to one directory, and then we will move the reference sequence also to another directory. So it's just a way to organize the files. So we will say make the data, and then we will say make the data / Pascal, and then we are going to move all the Pascal files there. So we say mv star.fq.gz, then we will say data / Pascal because we are moving them there. Now it's done. So let's do an ls, and we will no longer find the files here, but we will find it in the data / Pascal. So we say ls data / Pascal. We are going to get the file. So this is what we want. Okay, so if let's say you have hundreds of Pascal files which are all paired and reads, then you can even get a number of samples, okay, by looking at the pattern, what is used to differentiate between the forward and the reverse reads. So if you take a look at this one, for example, we have R1 and we have R2. So these codes, okay, these texts are the ones which differentiate between the forward and the reverse. So once we have this information, okay, the text that distinguishes between forward and the reverse, then it becomes very easy for us to process the files. Okay, because that information is very, very important. It is key here. Okay, so we'll use that information to help us automate the process of mapping. And in principle, you can use this approach on lots of data sets. Okay, if you have lots of FASTQ, it doesn't have to be 3 samples as in this case, but if you have lots of data sets and you have that information that is used to differentiate between the forward and the reverse, then it's fine. So let's take a look at some. Let's say we want to get the number of samples. Of course, as a beginner, you may probably do this ls data slash FASTQ star, and you say wc dash l. This will give you 6. Okay, but 6, we know that we are dealing with per Henry, so we can just divide by 2 and get the number of samples. But if you have hundreds or thousands of samples, then you don't need to do that. You can just query for just the forward or the reverse. So let's say we are using the forward reads, the information for the forward reads to get a number of samples. We can say ls data slash FASTQ, and we say star underscore r1 dot fq dot gz. So this will list them first, but if you want to count, you can issue the same command and use the pipe and say wc-l, and this will give us 3 samples. It's very, very simple. Okay, so this is how we do it. Now let's proceed. We are now going to move the FASTA file. Okay, this file here, the reference sequence, we are going to move this to another directory. So we will create that directory also in the data. So we say make the data slash ref. Then we are going to move it there. So we say mv ag19, and then we say data slash ref. So I'm doing this because I want to organize my files. It makes things easier for me. It also helps me to avoid accidental modification of files. Okay, so I mean that's why it's important to always make sure you put files of the same type in one directory. Okay, or files that you are going to process together, you put them in one directory so that it becomes easier for you to get them and then use them for your analysis. So that's it. So let's proceed. You should also know that if you have your FASTQ files, if you have your raw reads, it's advisable to perform quality control. So this will help you to assess the quality of the data and then identify possible problems and then use tools to actually resolve those problems. Okay, so that's something you have to do. But I've covered some tutorials on that, so I will leave some useful links for you to check. You can also reach out to me and then we can discuss further when it comes to the quality control. So that's what you should do. The focus of this tutorial is to show you how to map reads to a reference sequence. Okay, and also automate the process if you have lots of samples. So that's why I'm not going to cover quality control. So let's proceed. Okay, so now we have our reference sequence, we have our FASTQ file. So we are now going to perform the mapping. So what we are going to do first is to index the reference sequence. Okay, we are going to perform the mapping using BWA, but we need to index the reference sequence first. So let's do that now. So to index the reference sequence, we say BWA index, and then we have to specify the file. So it's located in data slash ref. So we say data slash ref slash ag19 underscore cr underscore chr8.fa. So this is the file. So let's index it. Okay, indexing has been done. So let's do an ls into the ref directory. Let's clear the screen first, and then let's say ls data slash ref. We are going to find some files generated in addition to the FASTA file. So we have them here. So we are good to go. Now we are going to map the reads to the reference sequence. So let's do an ls again to the FASTQ directory. So ls data slash FASTQ. So we have them there. So we can now proceed. So this is where we are going to write a bash script to map the array. So each of the samples will be taken and then mapping will be done. So this is where the automation starts. And in principle, you can apply whatever I'm doing here to your own data set, provided you have the right naming convention. So let's start. So first of all, if you want to map a genome, if you want to map reads to a reference sequence using BWA, the command goes something like this: BWA mem -t, and then you indicate your number of threads, let's say 10. Then you indicate your reference sequence, and then you give your R1, let's say R1, then R2. And then you can generate your sum file, or you can proceed to sort the reads straight away. So in this tutorial, what I'm going to do is to do a one-liner command to map the reads and then also sort the alignment records for us. So that's what we are going to do. Okay, so that's it. So that's what we are going to do. But in principle, you can also change it and then just use the unsorted. That's also fine. Okay, so let's proceed. So, okay, so let's do it this way. I'm going to write a script that we can use to just map and generate the BAM file. And then we will modify the script again and then sort the BAM file. So I just want to make it simple for beginners to understand. So that's what we are going to do. So let's clear this one first and then let's go back. So let's say we want to map just this one. I'm just doing an example here. We are using just one sample here. So then it becomes BWA mem -t, let's say 10. Then we indicate our ref, which is data slash ref slash ag19 underscore chr8.fe. Then we indicate our FASTQ file. So we have this and then this. So now I'll have to indicate my read one and then read two. I'm using further. Okay, so this is the part data slash FASTQ, and then I'll also give the file name. So I'll just copy this one. This is the R1. So I'll say data slash FASTQ slash, then I'll paste it there. Then that will be for the read one. Now read two will be data slash FASTQ slash this one here. That's R2. I'll paste it. So that's what we have. So what we are going to do next is to convert this output into a BAM file. That is what we ultimately want. Okay. So I'll just use a pipe command. Then I'll say some tools view. I'll say -shb. Then I'll say -o father.raw.bam. Then I'll say dash like this. So the dash here means that the output from this operation, this command here, should be used by some tools. So this dash here means that some tools will use the output here. That's what this simply means. So that's what we have. So this will be the raw BAM file. That's why I've given it .raw.bam, because this BAM file, we will have to process it again. So we need to have a name that will kind of describe it for us. So that's what we have here. So I'll run this command to generate the BAM file. Okay, the mapping has been done. So let's check the file. Let's do an ls, and we are going to find this file there. There's a raw BAM file. So we can sort it. So we can say some tools sort. We say -at to indicate number of threads, which is 10. And we say -o, say father.sorted.bam. Then I'll indicate the input, which is father.raw.bam. So let's sort this BAM file. Okay, the BAM file has been sorted. So let's do an ls, and we are going to find the file there, which is this one here. So this one, you can use it for your variant calling and other downstream analysis. Okay, so let's proceed. So we've done this, but what we've done so far is not elegant. Okay, if you have lots of samples, then it can be problematic. The first thing, these BAM files, we need to put them in another directory, okay, so that we are able to better organize it, so that we avoid accidentally modifying them. So we need to put them into another directory. So that's what we have to do. First, we should have done that immediately after doing it, but I'm just using it to explain why it's important to do some of these things. So that's what we should have done. And then number 2, this command, this one, and then this one, we can combine all of them together. Okay. So instead of me using sum tools view here, I could have just issued a sum tools sort to sort it, but we will do that in the other commands that we will use. So it's just to demonstrate to you that we can shorten some of these commands. Okay, so that's what you need to know. So you can just do it. So if what you want at the end of the day is a sorted BAM file, then you don't need to generate this raw BAM file. You can just combine the BWMM command with the sum tool sort to get your sorted BAM file. You can proceed with your analysis. So that's what you need to do. So the next one we are going to do, we are going to sort it. We are going to eliminate this intermediate, the file.raw. Bam. So we will omit the sum tools view command. So take note of that. Okay, so we have done this. Okay, let's take a look at this command. Now with this command, we had to specify, everything from data/ref/ag19. That's for the reference sequence. We had to specify the Pascal files, the R1 and then R2, that's forward and then the reverse. And then we also had to do this. Okay, so the problem comes when you have lots of samples. When you have multiple samples you want to analyze or you want to map, then this is where automation comes in. So I'm going to give you some tips. I'm going to give you some advice. I'm going to demonstrate to you how you can use some bash commands to automate this process of genome mapping, so that once you have your data set, you can quickly use them to just get your stuffs done. So that's what we are going to do next. So let's clear this first, and then let's do an ls into the data/Pascal directory to get the files. Now let's look at this. So with the Pascal files, these are paired and reads. So we should have a way to distinguish between the R1 and then the R2. That's the forward and the reverse. Here we are using R1 and then R2. And in some cases, people will use maybe father_1.fq.gz, father_2.fq.gz. And some will even use .fastq.gz. Okay, but the most important thing here is what will be used to differentiate between the forward and the reverse routes. That is what is important here, because once you have that information, then it becomes very easy for you to do the mapping. So that's what we have to look at. So I'm going to show you. Let me open another tab here. Let me do an ls again into the Pascal directory so that we can see the files. So I'll be switching between this and then this. Okay, so let's open a bash script. I'll use nano, but I can use any text editor. So I'll say nano, and then I'll say map.sh. I'll open it. I'll add my shebang line first. Then I'll move down. So that's what we are going to do. First, we are going to assign our reference sequence. We are going to assign it to a variable. So we can say ref equals, and then we specify the path. It's data slash ref slash what, ag19 underscore chr8.fa. Let's just confirm here. So let's into the ref directory to see. So there's it. So I have it here. I'll just copy it just to be sure, and then paste it here. That is the ref. And then when we come down here, we can also do this. We can specify the directory that's the FASTQ files are. Okay, we can do that here. But anyway, let's proceed. First of all, we need to get the FASTQ files. So this is where the other trick comes in. I'm going to give you a generic approach. So this is what we have. This is forward and reverse. So what we are going to do is to just get only the forward, the sequences here, the reads, just the forward. So that means we will get R1, R1, R1. That's what we are going to get. So that's what we will do. So we will just say read 1 equals, and then we will specify the path. So that will be what? Data slash pascal slash star underscore R1 star. Let's use this. Okay, this is read 1. Let me just change the variable name here. Let me just say reads. Let's make it simple. So these are the forward reads. Let me put it here. So I'll say forward read. So I am using forward and then R1 interchangeably. Okay, so forward or R1 means the same thing. So take note of that. So these are the forward reads. Let me just change this. Let me just use one word. Let me combine it. So forward reads. So this is what we have here. I will just copy it to this terminal just so that you see what I'm talking about. So I'll just paste it here. Okay, I'm going to just do some tries here. So normally with the scripts, you can also do some interactive sessions whereby you execute some of the commands in another terminal to test if everything is working. So that's what I'm just doing here. So as I'm teaching you this, I'm also giving you some best practices and then some tricks you can use to process your data. So once I get the forward reads like this, I can write a loop statement, a for loop statement to iterate and then get all the forward reads, and then from there I will add additional information to it so that we can get our reverse reads. So let's look at the for loops. I will just issue one here. So here I will just say for forward read in dollar forward reads at, because this is an array, so that's why I have it this way. I say do echo dollar forward read. I'll say done. Here we are just going to display the forward reads. That's it. So these are the forward reads. So this, what we have here, the 3 files here are the ones that will be in this particular outputs. Okay, so the forward reads, the 3 files are the ones that are going to be assigned to this variable here. So it is these 3 files that we are going to use and then get the other files. So notice we display them. So this is R1, R1, R1. And then this is where the text that is used to distinguish between the R1 and the R2 comes in handy. So R1 is for forward, and then the R2 is for reverse. So here what we can do is that for each forward read that we get, we can just change the R1 here to R2, and then we get the name for the reverse. That's simple. So here we can use the set command. Okay, so let's just do this. Let's just say we have this. Let me just give an example here. I can say, let's just say forward read. We are testing, so it should be fine. So if I want the reverse, this is what I'll do. I'll say reverse read equals, and then I'll say dollar, I'll bring a bracket, I'll say echo dollar forward read, I'll bring a pipe, and I'll say sed, I'll bring a quotes, I'll say s slash r1 slash r2 slash gen. So this command will swap or replace. So wherever there is r1, r2 will be placed there. So as we have r1 here like this, the r1 will be removed and then r2 will be placed there. So this is what can be done. So now I'll bring our brackets again. So the whole operation here, okay, the dollar here indicates that the value, what we get from that whole operation, should be assigned to this variable. That's what we have here. So let's run this. So now let's say echo dollar reverse read. So notice we have what? R2 there. Okay. Now let's expand this command before we put it in the script. This command here. Okay. So let's issue this. So here we say do. Here we can say reverse read equals, then we put this same thing here, this one here. Then we can add our colon again. Now we can say echo dollar forward read. We bring echo dollar reverse read. We say our semicolon again and we say done. So let's run this command. So you notice that we have R1, R2, R1, R2, R1, R2. Okay, so that's what we have here. So this is what we are going to use to process these files. And so again, you can apply the same technique, okay, the same procedure here on your data, provided you have a naming convention that can be used to distinguish between the R1 or the forward reads and then the reverse reads, which is R2 in our case. So that's what we are going to. So it's the same command. So I'm going to just copy them to the scripts. Then I'll add some information here. So I have this forward reads, but before I even issue the scripts, I also need to create a directory that will be used to store the output file. So I'll say make the, we should have even done that first. Let me just put it here. So I'll say make the bumps before I come to this one here. Now I'll issue the for loop. So I'll just do a copy and paste for this first one here. Then I'll paste it here. Let's check to make sure everything is okay. Okay, so in the bash script, we don't need to use the colon. We can just move to another line. So the next line, we will say do. And then we'll bring this one here. This command. There. So now we have the reverse read as well. There's another thing we also need to do. We are going to specify an output file. Okay, so let's go back to this other terminal. We have father, we have mother, we have proband. So we would like to use the same prefix here, father, mother, and then proband, so that we know that the BAM files are for the respective samples here. So that's what we do. So that means that the information here, we need to strip them off. Okay, so let's look at how we can do this. So let's just do this. Let's come here. I know this pattern. So let's just use the forward read again. So I'll say forward read. I already have it here, so I'll just copy and paste this one here. I'll say equals and I'll paste that command there. Okay, so we are going to get the output name. So the output name is going to be, when I say output, I mean the output file name, the BAM folder we are going to generate. The name is going to be father.bam. So I will need to strip off everything here and then get only the father. So I'm going to show you how to do this. Let me just clear the screen and then start from a new one. So I'll first do an ls to get the Pascal files. Okay, let me bring this one here again. I have forward read. Okay, yeah. Okay, so this is what you're going to. So I have this. So I'm going to issue this command. So I'll say output file name equals, and I'll bring a $sign. I'll bring a bracket and I'll say base name, and then I'll say $forward read, and then I'll bring this one here, this text here. I'll just copy and paste here, this one here, and then I'll close the brackets. So what is going to happen is that we want the base name. So the base name is this one here. But then we have also added this information so that this one will be stripped to be removed for us. So the base name will remove the part, the directory, everything here, and then we'll be left with just the file here. And then by indicating what you want to strip here, then bash will do that accordingly, and then you get your final name, which in this case will be this one here, father. Okay, because we are going to strip everything here. So if you have a file and then you want to get just the name, you can issue this command base name, you specify the file name, and then you indicate what you want to strip, and then you get the results. So this is how we are going to get the output file name. So let's run this command. So now if I do an echo $output file name, I'll get the name father. So it's very, very simple to do. So it is this command that we are going to place in our bash script. Okay, so now let's go back to our bash script and then add this information. So we are here. So we can say output file name equals, let's copy and paste the command because it's the same. And then we can now issue our bwmm command. So we can say bwmm-c, and we say 10. And note that the number of threads, we can also set it here, but we are using a fixed one here, so that's why I'm not going to change it. And now we can add our reference, which is $ref, and then I'll bring my forward forward read, and then reverse reverse read. Now I will sort the output here. So I'll add my pipe, and I'll say sum to sort number of threads to be 10. I'll say -o, and -o I'll say bams/$output file name, and then I'll bring .bam like this. Let's just use this. Let's bring a curly brackets here so that it becomes nice. And then we bring our dash. Let's add a description. So let's say .sorted .bam. That should be fine. So now the file, once it's generated, we will know what it is. So we have the output file name, which we had here, and then we added .sorted.bam. So you have father.sorted.bam, mother.sorted.bam, program.sorted.bam. That's what we are going to get. And then we have our dash here. Our dash here, okay, indicating that we are going to get the input from here. So what we get here will serve as input for this one here. Again, I repeat, what we get here will serve as input for this one here. So now we have done that. So let's move on to the next line. So now we can say done. And then we can exit and save the changes. And by the way, I'll make this script available so that you can use them without having to type everything. So everything is attached to this video. So I'll just save the changes. And then that is it. So now I'm going to execute the script. You can execute by using bash and then saying map.sh. That's also possible. Or you can use /, since it's in the same directory that we are now. But to do that, we have to add execution right. So we can say chmod +x map.sh. So now let's run the script. So I'll say / map.sh. So let's run it. So you will notice that the mapping has started. Okay. So let's wait for BWA to map all the reads to reference sequence. Okay, the mapping has been done. So let's check the files. So let's do an ls and we are going to find another directory called BAMS. So this has the BAM file. So let's ls into it. So you say ls BAMS. That will give us this output. So we have 3 files because we had 3 samples. Okay, so you'll notice that because we had this bash script, things have been made easy for us. Okay, so if you have hundreds or thousands of files, once you have the naming convention, then you can just write some simple bash scripts like we did. Let's do a cut to display it, this, and then you'll be able to automate your mapping activity. So this is how we do. So once you map your reads to the reference genome and you have the BAM files, what you can do is to check the mapping statistics just to see the percentage of reads that map to the reference sequence. Ideally, we should have majority of the reads mapping to the reference sequence. So you can check the mapping statistics to also do that. You can use a bash script to do that as well. In fact, we can do that here. Okay, we can actually do that here as well. But let's see, let's just check. We can just write a simple script. Let's check. Let's do that. Let's ls into the BAM. So what we have here, we can just do it. So for that, I'll just do it here. So I'll say BAMS equals BAM/star, because only the BAM files are in that directory. Then I can say for BAM in $BAMS do some tools flag starts, and then we say $BAM, then we say done. So let's run this. So this will display the mapping statistics for the 3 samples. So this is the first one, this is the second one, and then the third one. We can make the scripts more descriptive. At the moment, we don't know which is which, so we can just say, when you can say echo $BAM before we add the sum tools flag start. So let's run this. So now the flag starts command is being performed on the father.source.bam. Now it's on the mother.source.bam. Now we are on the proband. So there's something else that you can also do just to automate the process. So in a nutshell, bash scripting can make your life easier when it comes to processing files. Okay, when it comes to bioinformatics. So that is why if you are in bioinformatics, then one of the things that you are required to learn or you are expected to learn is bash scripting. You need to get your hands dirty with Linux command because you are going to use them a lot to process the files. Okay, so it makes the work much easier. So this is how I bring this tutorial to an end, and I will make the scripts available so that you can try your own on your own, or you can also try and then follow what I've done. And if you have questions too, don't worry, you can just reach out to me and then we can resolve whatever issues you have with regards to mapping ways to a reference sequence. So see you in the next video.